verified Kirchhoff's voltage law, we are now going to proceed with Kirchhoff's current law. Okay, and the Kirchhoff's current law states that the current that flows into a junction is equal to the current that flows out of the junction. So if for a closed loop, the current that flows into a junction, let's say A, is equal to the current that will flow out of the junction. So if you have current flowing here, let's say I1, and then I2 flowing to this junction, and then I3 flowing out of the junction. The currents, the sum of all the currents that flows into the junction is equal to the sum of all the current that flows out of the junction. So we can say that I3 is equal to I1 plus I2. Okay, so let's find a circuit that we can work with. So let's consider that from Bs, current flow through this loop and current flow through this loop. So considering R1 and R2, you see that there are two currents that will flow through R1 and R2. Both are having individual currents that will flow because it's a parallel circuit. When the currents get to this junction, let's say A, the current will split. So we have current flowing through R1 different from the current flowing through R2. But the voltage that caused the effect is the same voltage. Unlike the series circuit where we have different voltage drops, in this circuit, in this parallel circuit, we have only the same voltage flowing through all of them. So we can say that Vs is equal to V1 and is equal to V2. So the voltage here is the same as the voltage here. So from the relation, the voltage source is equal to the drop at R1 and the drop at R2. Now, what we have to say is the current through the various voltages and the various resistors are different currents. All right. So what we can say that Vs equal to IRT. Here we have to calculate for the total resistance in the circuit. For a parallel circuit, calculating the total resistance, you have to say 1 on RT is equal to 1 on R1 plus 1 on R2. Right. So if you want to find the current, actually current in the circuit will become Vs on RT. I is Vs on IR1 plus IR2. So let's call this our first this will be our first equation, second, third, and then fourth. Looking at this, we can use this relation, the first relation, and develop this, that Vs is equal to I in the circuit times 1 R1 plus 1 on R2. Again, we can say that V1 is I1 R, I1 R1. V2 is I1 I2 R2. I1 is equal to V1 on R1. If we have to do so, let's not forget the fact that V1 is the same as the V, since we have this, the source of the voltage is equal to the drop at V1 and then the drop at V2 because they are in parallel. Okay, With the relation V being equal to IR, you can say that I1 is equal to V, which is V is IR. So IRT on R1. Let's not forget the fact that RT is also 1 on R1 plus 1 on R2. So we say I1 is equal to 1 I actually R1 uh, times 1 on R1 plus 1 on R2. When we change this, we can get 1 V I1 equal to I on R1, okay, times R1 R2 on R1 plus R2. So if you want to find the current in resistor 1, this is what we do. We use this. Let's see if you want to find the current in resistor 2, which is I2. We'll have to use the same relation. We say I2 is equal to V2 on R2. Please, let's not forget the fact that this is paramount in this derivation. Vs is the same as V1 and is the same as V2 because it is a parallel circuit. So by seeing V2 here, I can place it, I can place the V1, I can place the Vs as well. So we say I1, I2 is equal to I times RT all on R2. I2 is I times, let's not forget, R1 times R2 on R1 plus R2 over R2. Again, this R2 is going to nullify this R2. So we end up getting I2 equal to I R1 on R1 plus R2. This is another expression we need. Let me call this. Okay, well, it's okay. So we are going to use this to calculate for currents in I1 in resistor 1 and resistor 2. We can also use the same to calculate for the total current in the circuit because Kirchhoff's second law says that the current that flows out of the circuit or a junction is the same as the current that enters the junction. So